Hi guys, in this series I'd like to show you how to build a full-stack application using Elixir and React. On the backend we will first build a GraphQL API using the Phoenix framework and Absinthe, which is a full-fledged GraphQL implementation for Elixir, and we will be using Postgres for the database. Then we will create a single-page application using React with hooks, and we will be talking to the API using Apollo Boost. The application we're going to build in this series will be a to-do list. It's a very simple project in terms of features, but we can use it to cover many important topics that we can build upon in more advanced projects. Now, in order to follow along with this tutorial, you need to have Elixir, Node, and Postgres installed on your machine. You can check if you have Elixir installed by typing iex-version. Here you can see that I'm running Elixir 1.10.2. And let's do the same for Node. Node --version, and you can see that I'm running Node version 12.16.0. And now for Postgres, psql-version, and I have Postgres 12.2 installed. And if any of these dependencies are missing, you should take a pause and install it before you go ahead. The way you do it depends on the operating system you're using. If you're running macOS, then you're in luck, because you can just install all of these using Homebrew, and if you're using a distribution of GNU Linux, such as Ubuntu or Debian, you should be able to find some versions of Elixir and Node in the system repositories, but they will likely be outdated, so that when in doubt, please refer to official installation guides. Now, another way to install Elixir and Node is using ASDF, which is a universal version manager. And if you like to install many versions of Node and Elixir, I highly recommend you take a look into ASDF. Now, in the following part of this video, I'm going to assume that you already have all of these installed. Now, in order to create a new project with Phoenix, you first need to install the Mix PHX new generator, which creates new applications. And in order to install it, we will go to Hexdocs into the documentation of Phoenix. And we will take a look into installation guide, and then down in this document there is a command that you have to copy and paste into your terminal. Now this command will install the PHX new generator. In fact, I already had it installed, and we can now use this command, the command we just installed, to create a new project. The command is mix phx.new. And then what follows is the name of the project. I will call it to-do list. And press enter. And the generator has just created several files for us, and then it will offer us to install dependencies. These dependencies will be Elixir dependencies as well as dependencies for Node, because the Phoenix framework comes with batteries included, and it has Webpack configured. Now, while these dependencies are downloading, we can go to a new tab and take a look at the files we have just created. I opened them up in Emacs, but you can use any editor you like. The structure of of a new Phoenix application is fairly simple. There is the assets directory, which contains the front-end files. There is config used for configuration. Dependencies is where Elixir dependencies are installed. Lib is where our application lives, and the priv directory is for private files of the applications. And there is test for unit tests, and formatter is the configuration file for the Elixir code formatter. Mix.exs is where we configure our dependencies. We will now install two Elixir libraries that we will need to build a GraphQL API. Let's open up the mix.exs file that is located in the project root. When we scroll down almost to the bottom of the file, we will see a single function called deps. And this is the function that defines our dependencies. It returns a list of tuples, and each one of these tuples represents a single library with a version number. So let's jump to line 45. And after the tuple that requires plug cowboy, I add a comma, and in the new line I add the I add a tuple. The first element of the tuple is the name of the dependency as an atom. So first a colon and then absinthe. And as of this recording, the latest version of Absinthe is 1.4.16. And another library I have to install is Absinthe_Plug. And this is a library that connects Absinthe, the GraphQL engine, with Phoenix. The latest version of this library is 1.4.7. And if you are not sure what the latest version is, you can check on hex.pm. And in my case, I will type Absinthe_Plug. And we can see that the latest version is indeed 1.4.7. So let's jump to the terminal and type mix deps.get, which will fetch the libraries. And before we start implementing a GraphQL API, we also need to create a database for our application. So the command to do this is mix actuall.create. And it will first compile our application, and the in this command, ecto is the name of a library that talks to the database, casts our data to correct types, and does validation. So it's kind of like an ORM, but we can't really say it's an ORM because Elixir is not a functional, it is not an object-oriented programming language, and therefore there are no objects. So we can see that the database has already been created. Now that our database has been created, we can start crafting our GraphQL API. So I'll go back to the editor and open the file tree, and we can see that in the lib directory, in this to-do list web subfolder, we have files that are related to our application's web layer. In this directory, I will create a directory called API. And inside of this directory, I will create a module called schema.ex. And this file will contain the actual main file of our GraphQL schema. It has to be an Elixir module, so I will create the dev module to-do list web.api.schema. And this module has to be using absinthe.schema. And in order to create a first meaningful Absinthe schema, we first need to define at least one query, and Absinthe, it doesn't use GraphQL for definition. It uses Elixir macros that get converted to actual GraphQL schemas. So we write everything in Elixir code. There is a macro called query where we define a hello world query, and this will be just a query that returns a string. And in order for this to work, we need to define a resolver. And there is a resolve macro that accepts a function that one can have the arity of either 2 or 3. In this case, we don't care about the arguments to the query. So you can just define underscores for bindings. And then we have to return a tuple. And the first element is the atom OK. And the second one will be the actual string hello world. And we save a file, and now we need to plug this schema into our router. So go to the file lib to-do list web router ex, and down there in the line 22, I'll comment this, and there are 2 routes that we need to provide. One will be post/API. And it should point to the schema that we actually created. And there is a plug called Absinthe.Plug. And it accepts a list of options. The option will be to-do list web.api.schema. And then another will be the playground, the GraphQL playground, which we probably want. And I will do it on the same endpoint, but on the get method. So get slash Absinthe.Plug, and the plug is called GraphQL because it used to provide GraphQL, but we obviously we don't really want to use GraphQL anymore because it's slightly dated. So we will define it in a moment. We have to give it a schema. It's the same module. And interface playground. Oops. And let's see if this compiles. I see. Here I typed Absinthe.Plug.GraphiQL, but because this scope gets a second argument, to-do list web, and the to-do list web would be prefixed with to-do list web, so I have to delete this argument. And let's see if this compiles right now. It does. I will now spin up a server. And when you go to the browser, we see at localhost port 4000 we see the application, and if you go to /API, we should be able to see our GraphQL playground. On the right, we have our schema, and the introspection gives us the shows that there is in fact this hello query we just defined. And let's try to run a query against the schema. Hello. And it does indeed return hello world. So the next step will be creating some data structures so we can store our to-dos. And Phoenix has a lot of code generators that can simplify this task. So there is one in particular that we will use right now. It's called mix.phx.gen.context. And it will create a context, which is a module that interacts with data, and I will call it to-dos. The second argument of this generator command is the name of the actual schema. I will call it item. And the third argument is the table name. It will be the plural of the schema, which is items. What follows is the list of columns in the table, and the first one will be the content, which is a string. And the last one will be a timestamp, which defines whether the to-do has been completed or not. So I will call it completed at, and the type is UTC datetime. And we can go back to the editor and see the migration that was created. It does indeed look okay, but I will add null false, so the column will not be nullable. And then I will open the schema that we have just generated, and it does indeed look okay. However, I just noticed that it does require us to specify a completed at, which is not what we want. So let's delete this and save it right now. And now we can run the database migrations by using mixed migrate. And the next thing that we're gonna do is create a query that fetches all to-do items from the database. So in order to do this, we go back to let's go back to schema.ex, and I will create a new type. I will call it TodoItem, and let's define its fields. Firstly, I will create a field for its ID in order to see its primary key, and it's a non-nullable ID. This corresponds to ID exclamation mark in GraphQL. And the next one will be content, which is a non-nullable string. And the last one is a timestamp, but we don't really want to show the timestamp to the user, so we'll make it field is completed. And it's non-nullable boolean. And in order to return this from the database, we need to provide a resolver function. and there is the resolve. Once again we'll use the resolver macro, and if we give it a function with the arity of 3, then the first argument will be the object itself, and we can pattern match on the completed at timestamp. And the second argument is the arguments to which we don't need, and the third one is the context. So let's return OK, not is nil, completed at. And the next thing we have to do in order to actually fetch these TodoItems will be to provide another query. And I will make it in here. I will fetch fill TodoItems, and it's a non-nullable list of TodoItems. And this corresponds in GraphQL to TodoItem, like this. And in here, let's provide a resolver, but I will create a separate resolver module for this later on. First, for now, let's just say function, and also here we also don't care about the arguments and the context. So let's return OK, to-do list that to-dos list to-do list items. This is a function from the module that we have just generated using mixphx.gen.context. And if you're not sure what this function does, we can open ix-s.mix, and this will open a console. And in this console, we can see what this function does. There's this module to-do list that to-dos, and it has the function list items. And we see that what this function does is query the database, selecting everything from the table items. So it looks like this is exactly what we want. So let's jump back to the API playground, and I will reload the window so we can have a newer database schema. Oh, it's not here. What happened? Let's see if it works. I will create a new query, and oh, it's not working. This is peculiar. Oh, I see. I think I misspelled this right now. It should be resolve. Let's see if it helps. It doesn't. It help. Now we have this TodoItems query, and it does have a non-nullable content, non-nullable ID, and is completed as a boolean. So let's query all of these, and we do get an empty array because obviously we don't have any TodoItems yet. So in the next step, we can create some TodoItems in the database. I suggest that you do it in IX because it's the simplest way to do it quickly. So we have this to-do list.todos module, and we alias it so we can access it more quickly. And now to-dos create item, and we pass it some arguments. And I will create a to-do saying with the arguments content, which is make a video about GraphQL, Elixir, and React. And we see that actuall has inserted this item into the database. So if you go back to the GraphQL playground, we can now say that the query is already returning the correct item. Another thing we would like to do is to create a mutation to create these items. And I will, in here, in the schema file, I will use the mutation macro to define mutations. So I will create a mutation called create TodoItem, and it should return for now, let's just return a boolean. It accepts the content it will just accept the text of this query, of this TodoItem, and it has to be a non-nullable string. And let's write a simple resolver. I will use the TodoItem version and content like this. And we don't care about the second argument. I will say case. We have this to-do list to-dos. I will alias this module right now, so we can use it more easily in this module. And down there, I will substitute it with to-dos. And in here, in line 22, in the resolver, I will say to-dos create item content, and if it returns OK and a to-dos item, then let's return OK true. And if it returns anything else, let's return OK false. So now let's jump to the GraphQL playground, and I will open a new tab and create a mutation. I will make this a bit bigger so you can see it better. Mutation create TodoItem, and this accepts content as a non-nullable string. And in here we create, I will refresh it, create TodoItem with content of content. And this field only returns a boolean, which is a scalar. If you run it now, it will say that we didn't provide the content. So let's add this content right now in here. And in this content, I will write, for example, let's say, write a decent mutation. And I run this mutation, and it does indeed create it to the item. And we can see in the log that it did indeed create an item. So if we jump back to the items query that we have created before, it should return 2 items. And the last mutation we're gonna need will be marking a TodoItem as completed. And this will also be a mutation in this file. And let's say mark TodoItem completed. Or we could also just say to toggle, because sometimes we could do it in 2 states, that if the TodoItem is completed, we may want to mark it as not completed, and if it is not completed, we want to make it completed. So we call it toggle TodoItem, and let's return the actual TodoItem. It may be nullable because the mutation we may pass some invalid data to the mutation, and it will accept the ID of the TodoItem, and it has to be a non-nullable ID. And the resolver function will accept it will be the TodoItem function, and it accepts the item ID, and we don't care about the second argument. And in here, I suggest that we write a separate function to resolve it. I will go back to the to-dos context, and I will create a new function for this. Let's define toggle TodoItem by ID, and this will accept the TodoItem's ID, and it will. I will write a guard so we can be sure that it is either a binary or a number, so we can see that its actual ID. When is binary TodoItem ID or is integer TodoItem ID. And inside this function, I will write it like this: case repo get item by TodoItem ID. If it's, let me make it like this so it returns nil instead of throwing an exception. If it returns nil, then we just return nil. And if it returns an item, let's update this item. I will update item with I will write a separate function to just toggle it. Def toggle item. If the item is completed, if it has nil, it means it's not completed, so I will update the item to say completed, and let's return a date time. Let's return the current time. I think we can get it like this. Yes, it works. Datetime UTC now. And if the item has some completed at, it means it's already completed. So we can just pattern match on the actual item, because this field can only have two possible values, either a timestamp or nil. So let's update the item with completed at is nil. And down in here, I will just call toggle item. And in the resolver function, we will need to return a tuple, but it's, let's say, okay, to-dos, toggle item, toggle to the item. I'll rename it to toggle item by ID because it's more consistent with the rest of the API. Toggle item by ID. And we cancel the item ID. Okay, let's see if it works. We have the to the items list, and I still haven't made a video about GraphQL, Elixir and React really, but I have already written a decent mutation, at least I think so. So I will create another one and see if I can mark this first to the item as completed. So we have this, I will reload the browser tab so we can see if this schema is updated. It is. I will go back to the new tab, new mutation, and I will make it accept an ID, which is non-nullable, and it toggles to the item with the ID of ID, and it should return content and is completed, and maybe the ID. Let's see if it works. It complains that I didn't provide any ID. So in the query variables below, I add the ID of 2, and I run the query, and we get an error. Let's see what happened. I think I know what happened. This is because, I think I know why it is, because in the toggle item, I use the update item function, which uses repo update. And repo update, by definition, it either returns a tuple with OK as the first element or error as the first element. So this toggle item will return a tuple, and this branch would return nil. So I will convert it to return OK nil, and the toggle item I will leave as is. So in the resolver, we remove the first OK, because our function in the context will already return a tuple. And let's see if that works. Oops, what happened? It did work, but okay, it did update it. Okay, I see what happened. We have the first time we run this mutation, it has already updated the item itself, but we just didn't get the correct result from the mutation. And the second time we run it, it returned nil because it toggled it. And the third time over, it also returns the correct completed add. So I think this wraps up this video, and to wrap it up, we have created a new Phoenix application. We have installed Absinthe and Absinthe.Plug. We have set up the Absinthe schema to work with the Phoenix router, and we have created one query and 2 mutations. Thank you guys, and if you like this video, please like it and subscribe, and let me know if you have any suggestions in the comments below. Thank you.